Hello, my name is Maya Showmaker, and today I will show you the 3 macromolecule flowcharts that I chose. Let's check it out.
All right, the first flowchart we're going to look at is for cortisol, the lipid-based steroid hormone. Starting in the smooth endoplasmic reticulum, it synthesizes cholesterol into steroid intermediates, and through enzymatic reactions, cholesterol is produced. Important to note that mitochondria is utilized, converting cholesterol into progesterone, which is a precursor for cortisol. And cortisol is a small lipid soluble molecule, making it easy to pass through the cell membrane through simple diffusion and ultimately is secreted into the bloodstream for regulation of metabolism, stress response, and immune response. Since it's a lipid and not a protein, it does not use ribosomes, rough endoplasmic reticulum, a Golgi apparatus, transport vesicles, or secretory vesicles. Moving on to the second flow chart, protein hormone, growth hormone, we start with the ribosomes. In the ribosomes attached to this rough endoplasmic reticulum, where the mRNA of the growth hormone is translated. And as it's being translated, it's moving into the rough endoplasmic reticulum, entering the lumen part of the rough ER, and undergoes folding modifications and the initial glycosylation of the growth hormone facilitated by chaperone proteins. Then the growth hormone is using transport vesicles to deliver to the Golgi apparatus where there's additional glycosylation and it adds, modifies, trims. And by the use of secretory vesicles, it remains in the cytoplasm until a specific trigger is released. Once that trigger is released, that cell membrane, the secretory vesicles fuse to the cell membrane and it exocytosis into the bloodstream to target specific tissues such as liver, muscle, bone, and to stimulate cell growth, cell production, and regeneration. And this process does not involve the smooth ER. Moving on to the last flow chart, which is the intracellular protein actin, it starts in the free ribosomes in the cytoplasm, and since it's not used for export or membrane insertion, it stays in the cytoplasm and folds into a 3D structure with the assistance of chaperone proteins and is the framework for the cytoskeleton and is a fundamental component of the cytoskeleton and provides structural integrity and enables cell movement and division. And it doesn't use rough ER, smooth ER, Golgi apparatus, transport vesicles, secretory vesicles because it is not intended to enter the endomembrane system. Thank you for watching my flowcharts. Hope you enjoyed.